ever heard of Joe Doucette and the Windwall? Well, I hadn't until my friend Dennis Kramer pointed it out to me, and I loved the look of it. Now, I'm not going to write to Joe and whine at him and tell him to show me exactly how to make it or prove it works before I spend my valuable time doing it. I loved the look of it, and I thought I'd give it a go because I've got a load of this stuff. This is A4, and it's the board that's used for making hardback books, and I've got loads of it. So I cut that into a load of 14 by 14 centimetres squares, because Joe's arrangement is basically a whole load like that on a stick in a big row, and he sticks them in the wind, and there's loads of these sticks together. I figured if I made them out this board I could always paint it, but it would be an easy way of doing something that would replicate what Joe had done, so I could see for myself if this thing worked or not. Now, I'm going to make 6 sticks, and they're 2.4 meters long. These are 14 centimeters, so clearly there's a lot of these to make. I've got about 200. Now, making those was easy because I've got a guillotine, so I just guillotined them off, but I need to mark them in the center. 7 centimeters, where I'm going to glue them to the stick. And whenever you're going to do something like that, then a jig is really the way to go. So I made a quick jig. You see, this is just a baseline, 7 centimeters away. I've driven a couple of nails, put a rod against it, and suddenly I've got myself a jig where I can draw at 7 centimeter centers. So just pick up a whole load, slide them in the jig, and we're off. And I've got a couple of hundred of these to do. Okay, it didn't take long to mark them all up, and I've laid out 16 of them, and every second one gets glued onto the stick, and for that I'm going to use some Gorilla Glue, and the stick I'm using is a bit of 9mm dowel. So I'll start here, and then every second one. On the second one, you start here. So the first one you start here, second one you start here, third one you start there, fourth one you start there, and so on, alternating them. But it's every second one that you glue. Okay, so I've glued them on, taped them down, and this is what we've got. Now we're about halfway there because we also have to put the ones facing that direction. But I'm not sure if this is essential or not, but I do like the idea of it. I've got some expanding foam, and I'm going to inject expanding foam into this little gap here to stiffen them up and make them a bit more waterproof by the time I paint them. So let's inject some foam in there. Okay, so when we put all those bits on and it's all had a chance to dry, this is what you'll get. It's about 2.4 meters long, and there's 8 of those little blades at 14 by 14. And obviously what we now need to do is put the center blades on. Now those blades in the gaps that are missing actually go at 90 degrees. So they're at 90 degrees there. Like that. We need to get those on. To get those on, we do the same thing. Line of glue here, line of glue there. Wrap it round, bit of tape, and then to hold it, a staple in the centre. And we need to do that for the other 8. And there they are, all on. So now what we do really is leave those to dry, then put the foam in, and we've finished the blades apart from one little adaptation. Looked a bit like a tank track, doesn't it? Anyway, I'll get the other ones done, and we'll get them filled. Okay, there's my 6 blades all made. Now we have to put these in a mount. Put them in a mount. The ends of the rods, remember I used this 9mm dowel all the way through. Well, it's got to go through a bearing, and that bearing is obviously going to be a wear point. So what I want it to do is have a metal piece going through there. So what I'm going to do, I feel like I'm using what I'm going to do a lot. What I'm going to do is take this bit of broom handle, chop it into 100mm sections, drill all the way through with an 8mm, drill all the way through, halfway through with a 9mm, then the 9mm section will go on the dowel rod, and I've got some 8mm bar, and I'll put the 8mm bar on the other side, and that will make the bit that will go into the bearing and that I can connect to the actual generator. Now, if you've seen that Joe Doucette thing, you'll see that these things move in harmony. And they move in harmony because they've been tied together. And I'm going to tie them together probably with a connecting rod where every second one is set at 90 degrees apart. That'll become clear when I actually make the frame. But I'm going to do something like that. And of course the other side of this, that connecting rod can go onto the other bit of steel at the other side. So in order to finish these blades, all I have to do now is make those wooden plugs. And that's our Joe Doucette wind wall rotating blade done. That's a bit of a mouthful, isn't it? Okay, so we've finished the prototype wind wall. Let's drag it outside and see if we can actually get it to work. Well, that was impressive all of its own. I mean, I've never seen anything do absolutely nothing before. Okay, there's going to be two reasons why that didn't work. One of them is a complete imbecile and built it badly. The other one is it was never had a hope in hell of working anyway. Now, I had a look at this thing, and it was very impressive. It looked real. It was only after it was pointed out to me that it was a render. And I looked again and I thought, yep, that's just a drawing. That's an animated drawing. In fact, this thing had never been made. I was the first person to make it. And that gives me faith in myself for a start, because boy, was a knock to my ego. And the other thing is it teaches me not to pay attention to drawings and have a look at things when they're real. However, I did really like the idea. I loved the idea. So I had a bit of a think about it, and I recast it like this. So this is still going to be lots of these. Obviously, because I thought it was made, I did put a lot of effort in and built 6 large ones. I didn't do that again. I built a metre size one, but I've changed the blades into this Savonius type because I have an awful lot of these cardboard tubes. So I cut the tubes off to 14 centimetres, tubes in half, Savonius type, and I've got myself a new blade arrangement that could be done as the wind wall. Of course, the very next question is now, does it actually turn in the wind? So let's take this outside and give it a go. Here is the original design based on the drawing, and we just tried that and found it tut, okay? Here is the one where I've taken the same concept but given it a bit of a curve in the Savonius type. This one works, that one doesn't. So obviously my next step is to make a whole bunch of these up into the wind wall, but instead of using the flat blade, use these curved blades. This stuff is UPVC guttering. It's a very standard product in the building industry in the UK. And of course what it is a semicircle. So it's going to increase the speed of how we can make that thing really quickly, because we just have to chop sections of it and arrange it in a Savonius type. Now it glues with UPVC glue, and remember it's a building product, so it's already built to last 25 years, and the glue joint is strong enough to take the kind of weather I get. I live by the sea on the top of a hill, so it's a very corrosive environment where I live, and this is meant to last 25 years in that environment. So we're going to use UPVC guttering that we chop up into sections to make our Savonius type wind wall. So in no time at all, we've got a whole load of half shells. Now I was going to do it like that, which is your traditional Savonius type, until my friend Wes Goodman pointed out to me there's an interesting bit of research which says that this 3-bladed system is actually the most efficient for Savonius. So I've glued together 3 blades. So I'm going to make a whole load of blades like that. Now the glue on this, you've got a choice actually. This is, remember, a standard building product in the UK, so you can use this UPVC pipe adhesive, which Bostik produces. A whole load of people produce that, or your favourite alternative, super glue, which glues UPVC beautifully. Anyway, all I've got to do now is make a whole load of those. Okay, so when we made a whole stack of them, we basically thread them on a bit of pipe, and I'm using wood as a spacer, and the wood's the same thickness. And then we give them a 60-degree offset, so they're staggered all the way up. Bit of glue, thread on the next one. So in the centre of all of those blades is a bit of pipe like that, and this bit of steel bar is the actual axle. So what we need to do is put the axle through the pipe and have it centred. Now what I do with that is I use a hole saw to cut out some of these foam board plugs. This is pretty stiff actually. The plug goes in there and you can see it's got a centre hole. We put another plug the other side and we can feed that axle down, and then the axle is nice and centred. So that's the blades all finished. Now of course it needs a box to go in, a bit of a frame, and I'm going to use this stuff, my favourite material, which is builder's board. The US, it's Sintra board. We get it here really cheaply. Dead easy to work, dead easy to glue. I'm going to build a frame out of this stuff. So I basically built 4 boxes out of that Sintra board, and they look like that. I haven't gone into it in detail because who can't cut and glue something together? So I've cut and glued these together, made 4 boxes, 1 for the top, 1 for the bottom, and 2 uprights. All we now have to do is take our blades, pop them into the bearings and put the top on, and we're ready to go. Okay, so to quote Mr. Michael Rook, that was a piece of art in motion, wasn't it? It was awesome. Hey, so that worked. Unfortunately, of course, the flat version that we got off the internet didn't work. The spiral arm version we just did worked awesomely. Now, obviously, we did both of them without a load on. There's no motors, no load. But I do have 6 of these NEMA stepper motors, and these NEMA stepper motors are what I'm going to attach to the bottom of those blades. Okay, I'm happy enough to admit I don't know when to leave stuff well alone. The sharp-eyed amongst you will have noticed the support structure has changed. Now, that's because I'm driven by 2 main things. 1, it's got to be easy for other people to replicate, and 2, it's got to be cheap. Now, I was thinking about the builder's board I was using. Builder's board is readily available in the UK, but not really everywhere else, and Sintra board, which you can get in the US, is pretty expensive stuff. So I went down to my local DIY store and bought a sheet of plywood, 18mm exterior grade plywood, 4 feet by 8 feet. Now, that cost me £43, and my local store has a cutting service. So I just gave them a list of what I wanted, and they cut the board down to all of the bits I need. So this is 1.4 metres by 200 centimetres, sorry, 20 centimetres, 200 centimetres would be huge, 20 centimetres, and I got the whole thing cut up for me. So all I had to do was come back together and screw and glue it together. And so it took me, start to finish, including waiting for this to be cut, 3 hours. Which is incredible really when you think about it, and the price £43, equally incredible. So this whole structure, minus the glues and screws, cost me £43. Now this is made out of drainage pipe, guttering actually, and I bought 6 pieces at £4 each, so it's £36 of those. If you add all the bits and pieces up together, this whole thing cost less than £100, which I think is absolutely awesome, because we've got the structure now there for £100 or less. It's actually less. The only other things we need obviously are these things, which are the connections, and I'll show you a close-up of those in a minute, and then of course my motors, which are going to be my generators. Now 6 of these motors will cost you about £40 or so. I had them lying around, but that's what they're going to cost you. So this entire structure will cost less than £150 and can be made by anybody with a screwdriver and some glue, which I think is really cool. These took a little while to make. They actually took me about 4 hours to make all 6 of them, so you're talking about a day and a half's work at a cost of £100 to £150. Because if you have spare motors, then you can just strap the spare motors on. And I'm a great one for scavenging motors. The only reason I'm using these NEMAs is I've got them, and they actually make a reasonable job of it. If you've scavenged any other motors, any of those motors are going to go on the bottom of here that connect as generators. So this thing is going to cost you between £150 or less, depending on what you scavenge. So you could put it together for no more than about £50 or so, which is incredible when you think about it. Anyway, I'm going to put these motors on and let's get on with it. So to attach the motors, I've put in this support bar, And then you can see that what I've been doing is using this flexible couple on the 8mm, so that goes on there, and then the motor just goes into the 5mm side of the flexible couple, making sure those are pointing outwards, and that's all there is to it. Make sure the motors are in line. I use these plastic strips here that you can see to resonate in that direction so they're in line with the axle. Now I've got to connect these up. Now you've got to remember these are stepper motors, which means they've got 2 coils on there and they do an AC output. Now the coils need identifying. I don't need to, luckily enough, because I have the wiring diagram, but it's dead simple. Just strip off the end, stick it in, connect 2 ends. If you get an infinite resistance, you haven't got the right coils, so you just connect 2 ends until you get a resistance reading, and that's coil 1, and the other resistance reading is coil 2. Kind of handy with these detachable cables, actually. Okay, so green and black for me are one coil, and red and blue are the other. And somebody wrote to me saying you're going to need 4 diodes for each one to make a rectifier. That's a lot of diodes, and yes, you could do that if you want, or you could buy yourself a bag of these things. These are rectifiers, actually, full wave rectifiers. They're 1000 volts, 2 amps, and they're dead easy to use. Now you can connect your coils up in series or parallel if you want, in which case you'll need one of these for each section, and you need 6 in total, so it's probably about 3p. I'm not sure what, but they were really cheap. I'm going to do them as separate coils because I'm interested in that. They've got something in mind that I want to play around with later, so I'm actually going to do them in separate coils. If you look at the end there, you've got plus minus, which is your DC out, and the other ones that are just with a squiggle line on them are the AC in, and it doesn't matter which one you put there. So you solder the AC to there, and the other 2, your plus and your minus, are going to be your DC out. Together, and then each coil comes out. There are 2 coils per motor, remember, and so we've got a rectifier on the edge of each coil, and there's my DC out, 2 outs for each coil, 6 motors, 12 coils. Now the only thing to do is to get this out into the wind. That was pretty awesome. So it works under load, it works with motors on, it works in the wind, and I did take some readings and we'll talk about those later. But first, let's have a look at it light an LED. So the original had 3 blades, and I've obviously remade it, and here is a subunit. So we've got a couple of bits of guttering right there, chopped up, glued onto a builder's board disc. Now this is 20 centimetres across, so 200 millimetres, and these are 14 millimetres high, and that's 9 millimetres, so we're talking about 15 centimetres. So I made 6 of those, which are right here, glued them all together on a steel axle to make my rotor. So there is my rotor. Now what I've done is offset every Savonius by 90 degrees. So you can see this one's flat, this one's pointing at you, flat, pointing at you, and so on. Okay, then I took 6 of those and put them into the original wind wall case. Okay, so this is built just like the previous one, only the subunit looks just like that, stacked up to make that. Now we're going to put them in the wind wall case and take it outside and have a look. Thing looks glorious. I mean, I just think it looks beautiful, hey? And remember, this is the kind of thing that you're not necessarily going to need planning permission for. This could be on a high-rise, it could be a balcony, it could be a separator, it could be a wall, it could be a whole host of things where you just stick it in there and nobody will notice it. It's going to be, looks like it's going to be super efficient and generate some really nice energy, as well as adding a decorative feature to your architecture. Anyway, thank you very much for watching, and please remember to like and subscribe.